There is a place on this planet that no human eye has ever fully seen. It covers more than 70% of the Earth's surface. It contains 97% of all the water on the planet, and yet we have explored less than 20% of it. We have better maps of the surface of Mars than we do of our own ocean floor. Let that sit for a moment. Right now, as you watch this, something is moving in the deep. Something large enough to register on sonar, something that has never been photographed, something that has no name because no one has ever seen it. The ocean does not frighten us because it is dangerous. The ocean frightens us because it is unknown. And the deeper you go, the more completely it becomes something that was never designed for human beings to understand.
This is the story of what lives in the dark below us, what the deep ocean actually is, and why the further down you descend, the more impossible everything becomes. Let's start at the surface. Right now, imagine you're floating on the ocean, somewhere in the Pacific. The water beneath you is warm. Sunlight filters down through the first 200 meters in shafts of blue and green. Fish dart past in silvery schools, sea turtles glide, dolphins surface and breathe. This is the sunlit zone, the epipelagic, and it is the only part of the ocean that feels remotely familiar to us. But 200 meters down, the light begins to fail. Not dim, not fade, fail. The sun, which has fueled every living thing on this planet for 4 billion years, simply cannot reach further than this. Below 200 meters, you enter a zone of permanent, total, absolute darkness. A darkness so complete that if you held your hand in front of your face, you would see nothing. Not a shadow, not a shape, nothing. And that is only 200 meters. The ocean goes down nearly 11,000. Between 200 and 1,000 meters lies a zone called the twilight zone, the mesopelagic, where the last traces of light die completely. The pressure here is already 20 times what you feel on the surface. Your lungs, if unprotected, would collapse. Your eardrums would rupture. The temperature drops to just a few degrees above freezing. And yet, life is here. In the twilight zone, creatures have evolved solutions to darkness so radical they seem like science fiction. The lanternfish, small, unremarkable looking, produces its own light through a process called bioluminescence. Chemicals in its body react to produce a cold blue glow that it uses to communicate, to hunt, to confuse predators. Lanternfish are not rare. They are, by biomass, possibly the most abundant vertebrate on Earth. There are more lanternfish in the ocean than there are all humans, all cattle, all birds combined, and most people have never heard of them. The hatchetfish has upward-facing tubular eyes designed to detect the faintest silhouettes against what little downwelling light remains. Its body is flat and silver, almost invisible from the side. It is an animal built entirely around the geometry of surviving in half-darkness.
And then there is the siphonophore. A siphonophore is not one animal. It is a colony of individual organisms called zooids, each one genetically identical but physically specialized for a different function. Some zooids swim, some sting, some digest, some reproduce. Together, they form a single coordinated entity that can stretch to 45 meters in length, longer than a blue whale drifting through the twilight zone, like a living ghost net, nearly invisible, trailing tentacles hundreds of feet long. The largest animal on Earth is not the blue whale. It may be a creature most people have never heard of, drifting in a zone most people will never visit. Below 1,000 meters, something shifts. This is the midnight zone, the bathypelagic, and here the rules of the world you know begin to dissolve one by one. There is no day, there is no night, there are no seasons, there is no surface, no sky, no reference point of any kind. There is only pressure, cold, and dark. The pressure at this depth is 100 times what you feel on the surface. It would crush an unprotected human body instantly. Not slowly, not painfully, instantly, like crumpling a paper cup. And in this zone lives the anglerfish. You have seen the anglerfish, the terrifying deep-sea creature with the bioluminescent lure dangling from its forehead, the enormous jaws, the needle teeth designed to trap anything that comes close. What you may not know is that the anglerfish you've seen in documentaries, the monster, is always female. The male anglerfish is tiny, barely a centimeter long. He is born without a fully developed digestive system. He cannot feed himself. He exists for one purpose alone, to find a female before he starves to death. When he finds her, he bites into her skin. His body begins to fuse with hers. His eyes dissolve, his internal organs dissolve, his blood vessels connect to hers. He becomes, in a biological sense, part of her body, a small, permanently attached reproductive organ that she carries for the rest of her life. This is not a metaphor. This is not science fiction. This is a real creature living in the ocean right now, beneath you, in the dark. If the anglerfish tells us anything about the deep ocean, it is this. Down here, evolution does not play by the rules we're familiar with. It plays by the rules of desperation. Below 4,000 meters, you enter the abyssal zone. The word abyssal comes from the Greek abyssos, meaning bottomless. The ancient Greeks used it to describe hell. It is not an accident that early ocean scientists chose this word for the deepest navigable plains of the sea floor.
The abyssal plain is flat, featureless. It stretches across the ocean floor like an alien desert, sediment thousands of meters thick, accumulated over millions of years from the slow rain of dead organisms drifting down from above. Scientists call this the marine snow, a perpetual silent fall of organic particles descending through the water column. Every dead thing in the upper ocean eventually drifts down here. The abyss is, in some sense, the world's largest graveyard. And yet, it is alive. Sea cucumbers move in slow processions across the sediment, processing the marine snow. Rat-tail fish glide above the floor, sensing vibrations. Isopods, ancient relatives of the common woodlouse, grow to enormous sizes here, a phenomenon called deep-sea giantism, caused by cold temperatures, high pressure, and scarce food. The giant isopod can reach 30 centimeters in length. It can survive without eating for over 5 years. In 2014, researchers discovered a species of snailfish, a soft, translucent, tadpole-like creature living at over 8,000 meters depth in the Mariana Trench. It was the deepest fish ever recorded. It looked almost gentle, almost peaceful. It glided through the crushing darkness as if the pressure that would kill every other vertebrate on Earth simply wasn't there. Science does not fully understand how it survives. The leading theory is that it produces a compound called TMAO, trimethylamine oxide, in concentrations so high that it counteracts the pressure effect on its proteins. It has essentially evolved its own chemistry to defy physics. At a depth where the pressure is 800 times what we feel on the surface, a small, pale fish is quietly going about its life. But nothing prepares you for what lies at the very bottom. The Challenger Deep, the deepest known point on Earth, located in the Mariana Trench in the Western Pacific, nearly 11,000 meters below the surface, deeper below sea level than Mount Everest is above it. If you dropped a steel ball from the surface, it would take over an hour to reach the bottom. Only a handful of humans have ever been there. More people have walked on the surface of the moon.
When filmmaker James Cameron descended to the Challenger Deep in 2012 in a specially designed submersible, he described the bottom as a vast, flat, alien world. He had expected a barren void. What he found was life. Small amphipods, microbial mats,
organisms processing chemical energy from the seafloor itself in a zone so removed from sunlight that they had built an entire food chain around hydrothermal chemistry rather than photosynthesis. There are entire ecosystems at the bottom of the ocean that have never seen light, that do not need light, that have never in their entire evolutionary history had anything to do with the sun that powers every other ecosystem on Earth. They are, in a very real sense, a parallel biosphere, a second origin of life, a world that evolved in complete independence from the world you know. And here's the thing that should genuinely unsettle you. We don't know what's down there. Not in the way that scientists say we don't know when they mean they haven't finished gathering data. We don't know in the way that means we have barely looked. The deepest parts of the ocean have been visited less frequently than the surface of the moon. The mid-ocean ridge, the longest mountain range on Earth, stretching 45,000 miles across the seafloor, was only discovered in the 1950s. We did not know it existed. A mountain range longer than all the continents combined, and we did not know it existed 60 years ago. In 1997, hydrophones, underwater microphones designed to track submarines, picked up an ultra-low frequency sound from somewhere in the South Pacific. It was extraordinarily loud, louder than any known biological source. Scientists named it simply the Bloop. For over a decade, its origin was unknown. The explanation eventually settled on, ice quakes from Antarctic ice shelf movement, is now widely accepted, but the fact remains, for a decade, an unknown, enormously loud sound from deep in the ocean had no explanation. The ocean makes sounds we cannot explain. It contains organisms we have never seen. It holds geological formations we discovered within living memory, and we have mapped less of it than we have mapped the dark side of the moon.
What does it say about us that the most alien environment on our planet is not in space, it's beneath us? That right now, in the Mariana Trench, a pale, translucent fish is navigating pressures that would destroy our most sophisticated machines? That a siphonophore, longer than a blue whale, is drifting through darkness we have never lit? That sounds are moving through deep water channels that we have only recently learned exist, channels where sound can travel thousands of miles without losing energy, channels that whales may use to communicate across entire ocean basins. The ocean is not creepy because of what we know is down there. The ocean is creepy because of the ratio between what we know and what we don't. Every expedition to the deep returns with something new. Every submersible dive photographs something that has never been seen before. The ocean is not a place we are slowly finishing exploring. It is a place where the more we look, the more we realize how little we have looked. There are an estimated 200,000 marine species currently known to science. Estimates suggest the actual number may be closer to 2 million. That means for every species we have identified, 9 more may exist that we haven't. 9 more for every one we know. The ocean has been here for over 4 billion years. It predates complex life. It predates the continents in their current form. It predates everything you have ever known or will ever know about this planet. And in all that time, it has been building, evolving, adapting, creating solutions to survival that our minds, shaped by sunlight and air and solid ground, were never designed to comprehend. So the next time you stand at the edge of the sea and look out at the horizon, remember this: you are not looking at the ocean. You are looking at the surface of the ocean. The smallest, thinnest, most familiar sliver of something that goes down and down and down into darkness, into pressure, into cold, for nearly 11,000 meters beneath your feet. And somewhere in that darkness, something is alive that has never seen light. Something is moving that has no name. Something is listening through water, through pressure, through 4 billion years of unbroken night to a world it will never know exists. And it has absolutely no idea that you are up here, wondering about it.